Hello, this is Dr. Mahmoud Al-Odeh for Quality Assurance. Today's topic is about control charts. I would like to go briefly over why we study and we use control charts, and then I will go take an example from the discussion on how we can create a control chart for a real-life example. So the control chart is it's a tool that we use to study the behavior of the process over time. And why this is important? Because we need to identify the variation. If there is any variation in the process, this variation should be eliminated. We have to find the cause, the resource for this, the cause for this variation, and then we have to eliminate this variation in order to have a higher quality process and more close to the target, more close to the tolerances that we set up. And in this chapter, we talked about the sources of variation, and these could be the common source variation or like the random variation, and this is just coming randomly because of the environment, and this is sometimes you can't avoid it. In order to avoid this, you need to change the whole process. But the assignable cause of variation, this is something that happened because of the reason, because a specific reason, and the causes could be identified, the source of these could be identified and should be eliminated, such as the poor training, if an old machine needs to be replaced, and etc. So these are the two common source of variation. Also, what I would like to do in order to study the process behavior, we use a set of charts, not only one type. It depends on the data that we have. So the first chart that we're going to study about it is the X chart, and this is related to to measure the central tendency, or the range chart, and this is to find out the difference between the largest and the smallest observation. In order to calculate the X and R chart, or in order to build the X and R chart, we need to use several techniques and several equations. So the first thing, when you see a question about the control chart, what you need to do, you need to find the center line, or what we call the CL. The CL, it's show you the average of the process, and we need to look the observation around the average. The more closer to the average, the better, and the less variation, because it is a less variation, and we get closer to the goal and objective. So the first thing that you need to do is to calculate the center line. The second thing, you need to find out what would be the upper control limit and the lower control limit. Okay. So in order to find out the center line, what you need to do, a set of observation, you have to observe the process for a few times. So if you take, like in this example that you see here on the screen, there are 5 observations for 5 steps. So what you need to take the average for each observation one by one and find out what would be the average for each observation. And then in the same thing we do for the range, find out what would be the range for these observations in order to find the center line. This is the center line. Next, what we need to do is the upper control limit and the lower control limit, and this would be calculated by finding the average of the average plus or minus 3 sigma. And the 3 sigma, the sigma is the standard deviation for the data. And there is an easy function that we could use in Excel to find out what would be the standard deviation, or sometimes you know that you have the standard deviation of this specific amount, and it's given sometimes in the question. So, or if you don't have the standard deviation, if you can't find the standard deviation, if it's hard to find the standard deviation, there is an appendix by the end of the textbook where you don't need to use that standard deviation. You could use the value A2 multiplied by the range of the average of the ranges. Let's go ahead and take an example, applicable example here on discussion 7. We have a set of data, the bottle volume in ounces, and this is for a company that would like to study the behavior of the process. So a quality control inspector at the Coca Fizz soft drink company has taken 25 samples with 4 observations, each of the volume of the bottles filled. The data and the computed means are shown in the table. So we have the table here for this example. If the standard deviation of the bottle operation is 0.14 ounces, use this information to develop control limits of a 3 standard deviation or 3 sigma for the bottling operation. So I did provided this data in Excel so you could focus on developing the charts rather than just entering the data. So we have 25 samples, we have 5 observations. First thing you need to do is find the average. And in order to find the average, what you need to do is use the function called equal average. Select that, select the cells on Excel, close the parentheses, and this is the average for the first sample over the 4 observations. The same thing for the rest of the 25 samples. Right click, double click on the right lower corner, and that will fill the averages for you. Now for the range, what you need to do is calculate the maximum minus the minimum for the set of the data. So equal maximum between these observations minus the minimum. So we have the minimum here to be we have the range here to be 0.19. Same thing, if you're happy with that, you take it and you apply the same equation for the rest of the cells. So again, equal maximum, select the data, the observation, the 4 observations that we have, minus the minimum, close the parentheses, and that would give you the range. You're happy with this equation, apply it for the rest of the samples, of the 25 samples. And now the next step is to find average of these averages. The average of these averages, again using the function average, select all this data here, close the parentheses. For the ranges as well, we need to find the average of the range. Select all of these, close the parentheses. Now we have the X double bar, we have the R bar, and now we're moving on to find the upper control limit, the lower control limit, and the rest of the data needed to calculate or to create the chart. Right here, and the sigma for the process, we know that the standard deviation for the process, it's given in the question to be 0.14 ounces. However, if this is not given and you really like to calculate the standard deviation, what you could do, you could say, I want to do the standard deviation, so equal standard deviation for the sample, and select the data, all the 25 samples from there, and that would give you a value close to what is given, which is 0.13, and what we have here, what is given is 0.14. Another way for doing it is take the standard deviation for the averages. Maybe this would give you a closer value to what is given. Not really. So I would think maybe using just the data here, the 25 samples, in order to find the standard deviation. And the function is stdev.s. Close the parentheses. Okay, so now assuming that we have the data, we have the standard deviation, we're going to go with the one that is given to us. Now, the next step we have to do, as I mentioned, whenever you have a question for calculating or creating the control charts, you need to find 3 parameters, 3 numbers: the center line, the upper control limit, and the lower control limit. So the center line, it would be the average of the average, which is we found it here. So that would be equal to this number in here. And in order to lock this cell, just add a $ before and after. This cell is locked. And for the upper control limit and the lower control limit, these are what we need to use, these equations that we could use. So let's go with, I'm going to copy them here, paste it on here, so we could maybe use both of them or one of them. It should give you the same answer. So for the upper control limit, start with this one. It would be equal to the center line, which is the 15.95, plus 3 times the standard deviation, which is the 14, and that will give you 16.37. The lower control limit would be equal the center line minus the 3 standard deviation, 0.14, and that will give you 15.53 for the lower control limits. And this is, we use this equation here, x double bar plus or minus 3 sigma. Now, if somebody will say, okay, I'm going to try the other way, which is the A2. Okay, well, we could do it. So let's go ahead and try it. So the lower control limit for that, we need to go to the textbook first. So let me see if I could access the textbook here. All right, here's the textbook. We'll go all the way to the appendix. Appendix 2. Perfect. Now, in this, how you read this table, you need to start with the observation in a sample. Now we need to know what's the observation. So we know that we have 4 observations for this particular example. So go with the A2 to be 0.729. So we're going to do this, copy this 0.729, and let's go here. Equal, start with the equal. The x double bar would be 15.95. This is the lower, so that would be minus the A2, which is, we have the A2 here, 0.729, times the average of the range, which we have it here as a 0.29. And that will give you 15.73. Next, we go to calculate the upper standard deviation. The upper standard deviation would be the x double bar, which is 15.95, plus the A2 times the average of the range. Close the parentheses, click OK. That would give you 16.1559. So now somebody will say these values are different. Yes, they're different because the A2 is based on estimation, and we're not sure if the sigma here is different or is it accurate, but both of them will be correct. Both of them will give you an XR. The differences between the values, it's not gonna give you a wrong number. It's not gonna give you that this process is out of control. It's not gonna tell you. It's not going to make any difference to tell you about the behavior of the process. It's still going to give you the same thing because what the risk is going to be around these values. So now we have the x double bar, we have the lower control limit, we have the upper control limit. Now let's go ahead and build the chart. So as in the segment right here, what you need to do is fill this in here. So we start with the sample mean, when this would be taken from here, and fill the cells with the rest because we need to copy exactly the values here from the average for each cell. And then for the control, for the center line would be equal to this number here, and lock that cell because we need to copy exactly the same value for all of these cells. Double click. Upper control limit, we have it here, 16.37, same thing. lock it because this is going to be constant. Apply it for the rest, and now lower control limit equal this, lock it, apply the same value for the rest of the cells. Now you go here, you will see that you've created the control, the X bar chart. Now let's go ahead and try these values. Is that going to make a difference with process if it's going to be out of control or not? So upper control limit. So we're going to do upper control limit here. We have to lock it and then copy the rest. And when I say lock the cell, that means just keep using the same exact cell that I used in that. The lower control limit would be 15.7. All right, so now let's take a look into the chart. Give me a really nice chart as well. It's still the processing control. We see still the observations is clustered around the average. I don't see any thing that tell us that the process is out of control. Now for the R chart, we're going to apply what we've learned. We calculated the R bar here. So now let's go to the use the equation for the R chart, and the equations for the R chart would be equal to these values. Okay, now upper control limit and lower control limit would be the D4 times the average of the R. So we know that the center line for the range would be 20.29. It's taken from here, G32. So we're going to take this G32. Now D3 for observation, what we need to do, we need to go to the appendix. And this is again what we're looking for. We're looking for observation, and we're looking into uppercase D3 and D4. D3 is a 0 for observation, and D4 is 2.114. So we'll go take these values, apply them here. Okay, so that's a 0 for the lower control limit. For the upper control limit would be the D value would be 2114. I'm going to double check on that because I saw something. So we're observation number 4. You're right here. It's actually 2.28, and this is just go through the arrow of 4 observation, go here, and that would be 2.282. Okay, so this would be 2.28. Now we have the D3, we have D4, we have the average of the ranges. Let's go calculate the control, the center line and the control limits. The lower control limits, we have to have it as a 0 because 0 times the 0.29, that would be 0. The same thing here. The upper control limit would be the D4 times the average of the range. That would give you 0.65. Now we'll go ahead and apply these into this table. So the center line would be 0.29, and apply this for the rest. Sample range would be equal to these samples that we have, the ranges for each of these samples. Double click. Upper control limit and lower control limit. We have the lower control limit to be a 0. Apply this for the rest. Upper control limit to be equal 0.65. Lock the cell so you can copy it for the rest. And now look at the chart has been created. Again, there's no out of control limits. All the data is within the control limits. It is a fun activity. It's a real activity. We've used it in industry all the time to calculate and create the control charts to observe the process if it's within the limits or out of the limits. Another thing that I want to mention quickly here, and again, I don't like to have a long videos, but sometimes you have to do it. There is a software that's used by industry called Minitab. So if you are one of the people who has access to Minitab, you could apply what you've learned here. Exactly the same thing. I'm going to show you quickly how we could do this in Minitab. So I took the data from the Excel sheet and I have it here. So I have it all here. Now what I need to do is just apply, create a control chart using Minitab. And again, if you have an access in your company, feel free to use it. There will be a segment on Minitab using Minitab. By the end of the semester, I want you just to make sure that you are able to use it. However, there will be also an opportunity for you to download it for free. And the reason for that, for not asking you now to do it, because there is a trial time for applying Minitab, and which is going to be like a 1 month or so. So I leave it to the end of the semester to practice and play with Minitab if you don't have access right now in your companies for Minitab. Now, okay, if I want to create a control, an X and control chart, what I could do, I go to Stat and go to Control Charts, and then go to Variable, Variable subgroup. We need to do we need to go to the R chart. Let's go try the R chart, X and R, X bar and R chart. So now we select the observation, and we need to select observation 1, 2, and 3, and select, and click OK. Let's see what is that going to give us. All right, perfect. It's right here. So now this one right here is the X chart for 25 observations, and this one is for the R chart for 25 observation. And if you look, they look the same as we created on Excel, but it's a more fancy and a more professional. And it's fun, actually. You don't have to do all the calculation. It's basically, I did not do anything except that I inserted the data, I entered the data on Minitab, and I went to statistics and clicked on the X and R chart, and it has generated for me. But versus Excel, you have to do the control limits and the upper control and lower control. You have to get some appendix from the appendix A to D3 and D4, and you have to do all the standard deviation, etc. So these are also time consuming. So I hope this is helpful. I'm gonna end up right here, but please let me know if you have any question. Thank you for your question all the time. I appreciate it. Thank you.